Hello everyone, I'm Adarsh Singh, a chemical engineering student of NIT Andhra Pradesh. I've qualified my JEE Mains in 2020. I warmly welcome you in this video where I'm going to take the subject JEE Chemistry. And the chapter is Chemical Reaction Kinetics, which is chapter 4 of class 12 NCERT. So before going deep into the chapter, let us firstly learn about the terms, what the chapter name says. And the terms are reaction kinetics. So the reaction plus kinetics. So what is reaction? Reaction is a process where a substance, that is reactant, converts to product. So we will define as reactant as reactant changes to product. Now what about kinetics? Kinetics is a study of speed of any process. So kinetics basically deals about the rate and we also call it speed. So it deals about the speed of any process. Speed of any process is called kinetics. Study of speed of any process is called kinetics. So in this chapter, the combined effect of reaction and its speed we are going to learn. So what we are going to learn is rate at which the reaction is going to progress. Rate of progress of reaction. So which reaction? Let us take an arbitrary reaction. A gives to product. A gives to product. So what is the rate of reaction defined for this type of reaction? So the rate of reaction for this kind of reaction, basically for every reaction, rate of reaction in general terms is defined as the change in number of moles of reactant species with respect to time. So we'll write here as change in moles of A, because A, we have taken this reaction, so A is our reactant with respect to time. So this is directly proportional to, so this is directly proportional to, rate of reaction is directly proportional to change in number of moles of A with respect to time. So let me write this as RA. RA is rate of reaction with respect to A. Is directly proportional to change in numbers like dNA by dt. Everyone know about this term. We write rate in this form only. So removing the proportionality sign, we will add a constant. So what is constant in this process? We consider its volume. The volume of the reaction is always constant. So the volume will come 1 by V dNA by dt. So this is our rate of reaction. Now we'll talk about the rate of reaction in terms of concentration. Wait a second. So rate of reaction. We have defined here rate of reaction as 1 by V dNA by dt. Okay. Now consider a reaction A gives to product. Okay. So let us take that at time t equals to 0, the concentration of A. In the NCERT book, it is written as this symbol. For my convenience, I am taking it as CA, C subscript A. So at time t equals to 0, concentration of A is Ca naught. Now at arbitrary time t equals to t, time equals to t, let us take the concentration as Ca. Okay. So what is the rate of reaction for this process? So rate of reaction is the change in number of moles, change in concentration of A with respect to time, that is Ca minus Ca naught upon T minus 0, because at time t equals to T we have Ca, at 0 we have Ca naught, so T minus 0. So we can see that A is disappearing here, so this Ca will definitely be smaller than Ca naught. So it will come as negative quantity. But rate and speed never be negative. So we'll take the negative sign common. Like with prior advantage, we are taking the negative sign. So we'll take it delta CA. So now we talk about the average rate of reaction. Average rate of reaction. Average rate of reaction is going to be minus delta CA by delta T. Okay. So we everyone know that delta CA is average, and we talk about instantaneous. So let me draw the graph of this. So if we take with respect to time, and this is the concentration. So this is the rate of reaction curve with respect to reactant. So we'll write here as reactant. Pardon me for my writing. And this will be the for the product. Okay, for product. So this is for average. If we will define, the average rate of reaction will be delta minus delta CA by delta T. But what about the instantaneous rate of reaction? What if anyone asks about the not at time t equals to t? If any arbitrary time, if someone asks about the rate of reaction, so for instantaneous, the rate of reaction will be the slope. Like if we are supposed to find the rate of reaction at this point of time t, so the tangent, that slope of this curve at this point will be the rate of instantaneous rate of reaction. So if we draw a slope here, tangent here, the slope of the tangent will be the instantaneous rate. So we'll write that instantaneous rate is equals to minus dCA by dt. Okay, nice. Now, without wasting the time, let's go to the deep. Okay, the main crux of this chapter is rate law. What is rate law? So rate law is the experimental expression. Meanwhile, I'm telling the definition. The rate law is the experimental expression of rate of reaction in terms of reactant. Okay, the rate law is the experimental expression which tells about the rate of reaction in terms of reactant. So let us consider the general reaction AA plus BB gives to product CC plus DD. It's just an arbitrary reaction. So now we'll take the rate of reaction by rate law. So we are talking about rate law. So rate of reaction. Rate of reaction will be K CA to the power A plus not plus, sorry, pardon, CB to the power B. Okay, it is not mandatory that every time the stoichiometric coefficient will be the power of this concentration. No, for elementary reaction only it happens that stoichiometric coefficient of the reactant becomes the power of the concentration. So if we write here rate of reaction, we know that in terms of A it's written as minus RA, because this is not a minus sign. It's just a signal of disappearance, that A is disappearing in this process. So RA is equals to K CA to the power A and CB to the power B. Now what is K? Let's talk about the each terms. Okay, so minus RA is rate. Okay, everyone knows. What is K? K is rate constant. What is rate constant? So rate constant, okay, let me finish the terminology first and later we'll come on this. What is CA and CB? CA and CB is the concentration of A and B reactant. A and B reactant. And what is this term? Main important terms, small a and small b. This is the term which tells about the involvement of concentration of A in the rate of the reaction. So A and B tells the involvement of A. Involvement of A and B in reaction rate. Reaction rate. And the combined A and B is called order of the reaction. So if we combine A plus B, it gives us order of the reaction. Order of reaction. Now this is our topic of interest here, order of reaction. So what is the order of reaction? Order of reaction is a experimental quantity. Like we cannot say by seeing the reaction that this is the order of reaction or this is the rate constant or anything. It's all the experimental derived quantities. So A plus B is order of reaction. So order of reaction tells about the involvement, combined involvement of reactant into the reaction rate. Like I say individually A and B are the involvement and of A individually in the reactant, but A plus B is the combined effect of involvement of reactant in the rate expression. So now I left at rate constant. Okay, so what is rate constant? Rate constant is an experimentally derived quantity. Again, once again, we are everything is talking about experimentally derived quantity. Rate constant is experimentally derived quantity which is constant for every reaction, but it depends on some factors. So what are the factors? It mostly depends on temperature. Rate constant mostly depends on temperature. There is one thumb rule also, like everyone should know that thumb rule, that Arrhenius says that at room temperature, near the room temperature, with increase in 10 degrees Celsius, the rate constant get doubles. Like for example, let me take the example. At 20 degrees Celsius, if rate constant is K1, so at 20 plus 10, that is 30 degrees Celsius, rate constant will be 2K1. And this will again directly affect the rate of the reaction. So definitely at this point, rate of reaction will be R1. So at this point, rate of reaction will be 2R. Okay. Now we'll talk all about the rate of reaction in this kinetics. So let me finish this part. Now this A plus B, that rate of order of the reaction, it's contain more information in itself. So A plus B can be 0, like order of reaction can be 0, order of reaction can be 1, order of reaction can be negative also. In fact, order of reaction can be fractional also. So A plus B can be positive, A plus B can be negative, A plus B can be 0, fractional, and anything. Okay, but it cannot be minus infinite and plus infinite. This is because if the concentration rate of the reaction will depend on infinite power, it's obviously of no use. That reaction is never going to happen, or that reaction is never going to visualize. We are not going to visualize that reaction. And in the moving terms, we are going to get one topic here is molecularity. So what is molecularity? It's a very interesting topic. So molecularity tells about the number of molecules which are colliding in a perfect symmetry, in a perfect direction to give us the product. Suppose this is the molecule. Suppose it's an arbitrary term, it's molecule, and this is one more molecule. Okay. So this molecule will not give product in all the cases. The molecularity tells us the same, that if this molecule combine in a good condition, that it have some enough energy to form product, and it is in the perfect orientation, because if this molecule converts collides in the form of this, like this attacks this, there will be no formation of product, so this will be of waste. So this is defined by molecularity. Molecularity of the reaction can be mostly can be 1, 2 and 3. Okay, mostly can be 1, 2 and in most like worst case it can be 3. And for elementary reaction is the most favorable reaction for the students. Elementary reaction, the reaction in which stoichiometric coefficient says all about the reaction. Like for example, say A plus AA plus BB gives to product. So if it's elementary reaction, see what's the benefit of elementary reaction. This molecularity will be A plus B. Molecularity will be A plus B. And even its order of reaction gonna be A plus B. So this is the benefit of elementary reaction. Now our interest is order of reaction, as we have started the discussion on order of reaction. So let us now we'll talk about the different order of reaction and its half life, its full life, and its derivation. So if order of reaction is first is zeroth order. So now what is zeroth order? A zeroth order is a reaction in which, like suppose a reaction A gives to product. Okay. Now what is zeroth order reaction? Zeroth order reaction is a reaction in which rate of reaction is independent of concentration of A. So its rate expression will be written as, rate law will be written as K C A to the power of n, where n equals to 0. So we can write Ra equals to K Ca to the power 0, which means K. Okay. So Ra equals to K. This is our rate expression. Okay. Now we have learned that another definition of rate of reaction, that is disappearance rate. So now let us talk about that. Minus dCA. This is what we have learned by dt. Okay. This is equals to K. Now we are going to integrate it. So dCA equals to minus K dt. Now we are going to integrate it. So my condition is at t equals to 0, Ca equals to Ca naught, and second condition is at t equals to time t, arbitrary time, Ca equals to Ca. Okay. Now I put the limit t equals to 0, Ca naught, at t equals to t, Ca. Now what I am going to get is Ca will imply the limit Ca naught Ca equals to minus K T 0 to T. I hope everyone is familiar with the reaction everyone is familiar with this integration term. So what we will get here is Ca minus Ca naught equals to minus Kt. Okay. Now this will become Ca is equals to minus Kt plus Ca naught. Now what is this looking like? It's looking like y equals to mx plus c. So let's talk about the graph of the reaction. Remember this, okay? I'm going to take this forward. Okay, I've left it. Okay, so we have Ca equals to minus Kt plus Ca naught. Okay, this is term y equals to mx plus c. So here m equals to minus k, y equals to Ca, and x equals to t. So let's plot the graph without any delay. So this is our graph. Okay, y equals, at y we are going to have Ca, at x we are going to have the t. Now our slope is negative and our constant is Ca naught. So this will be our constant Ca naught, intercept, sorry, and this will come like this. Okay, so the slope will be minus k. Okay, slope will be minus k. K is the rate constant of the reaction. Okay, and some more graphs are here also. Like we can also do like Ca minus Ca naught, Ca minus Ca naught equals to minus Kt, and if we will talk about Ca naught minus Ca, it will be Kt. So consider it as y. If you take it as y equals to mx, so c will be 0. So our graph will come like this. Our graph will on y-axis Ca naught minus Ca, and this axis t. Our graph will start from 0. Slope will be rate constant. Okay, fine. Now we'll talk about the half-life. What is half-life? Half-life is a time at which the reactant concentration become half of its original value. Like if at time t equals to 0, like starting of the reaction, if the reactant condition is Ca, at half life it will be Ca naught by 2. So T half at t equals to 0, Ca equals to Ca naught. So at t equals to T half, see how to write half life is like this. So Ca will be Ca naught by 2. So let me finish it fast. So Ca equals to, here if you put that Ca equals to in this equation. This is our main equation which we have derived. So Ca equals to Ca naught by 2 equals to minus K T half plus Ca naught. From here we will get minus K T half equals to Ca naught. Remove this, I am removing this minus here. Ca naught minus Ca naught by 2. From here I will get T half is equals to Ca naught by 2K. Okay. Similarly, 100% life. What is 100% life? 100% life is a time at which the concentration of A, reactant A, disappears. Like there is no reactant present in the reaction system. So at T equals to T 100%, the Ca equals to 0. So by putting in this equation again, 0 equals to minus Kt plus Ca naught. So T 100%, sorry. So T 100% for this first zeroth order reaction is Ca naught by K. This is our formula. Okay. Now let's talk about the first order without any delay. Okay. Due to time constraint, I have to move faster. First order reaction. Very important. First order reaction. What is first order reaction? The reaction in which the rate of the reaction directly depends on the reactant concentration. So if we have reaction like A gives to product, we are going to have the rate law, which I have already explained. Rate law is K Ca to the power 1. So 1 power 1 means that quantity itself. So rate law, rate of the reaction directly proportional to concentration of the reactant A. So by the previous term which we have discussed, minus dCA by dt equals to KCA. Again, we have to integrate here to find the terms, find the original reaction and the original equation of the first order reaction. So dCA by Ca gives to minus K dt. Integrating it again. Now I'm not going deep. At t equals to 0, Ca equals to Ca naught. At t equals to t, Ca equals to Ca. Okay. Integration 1 by x dx is ln x. So we are going to have ln Ca. Concentration is Ca naught to Ca is equals to minus K T 0 to T. Okay. So here we get ln Ca minus ln Ca naught is equals to minus K T. Okay. 0 to T is obviously T. So here we get ln Ca naught minus ln Ca. I think everyone understood that I bring that minus sign this side. It will be Kt. This is our one equation. I am going to show you the graph of this equation also, because graph is the most important, mostly as in the examination of JEE. In our time also this graph came. And now next we have to integrate it, so we can write it as, now we are taking this reaction, this equation, sorry, ln Ca by Ca naught. This is understood, I guess. It equals to minus Kt. Okay. So if I am taking it as, if I am directly converting it to this, it is called exponential of minus Kt. And at here, okay, let me write it clearly. Ca by Ca naught equals to e to the power minus kt. And if I send this here this side, it will be Ca equals to Ca naught e to the power minus kt. Okay. We have graph on this also. We have graph on this also. So let me fastly do it. I think time is also very less. Okay, let me do fast. So we have the equation ln Ca naught minus ln Ca equals to kt. This is our one equation. So if we write it as like this, ln Ca is equals to kt plus ln Ca naught. Is it in the right way? No, it's not in the right way. So we are going to, this will be plus, this will be minus, because the slope will be negative. So we are going to take as y equals to mx plus c. So slope will be negative. Here we are taking slope as minus k again. Okay. Now if we take the graph, okay. So in the y-axis we are going to take ln Ca, and the x-axis we are going to take the Ca time t. Okay. Pardon me for the straightening of this axis. This is 0. So at we have our intercept ln Ca naught. So this is ln Ca naught, and this is minus k. So this is. Now there is an intention in not touching this line to this axis, because first order reaction never get complete in finite time. I will explain you the mathematical terms also. So here slope will be minus k. Okay, and this is our second equation. So Ca equals to Ca naught e to the power minus kt. Now let's see the graph quickly. This is Ca, this is time t. Okay. So what is this? We have concentration, initial concentration Ca naught. Okay. At time t equals to 0, we have initial concentration Ca naught. Exponential curve, how it goes? Like this. It will never touch. It will touch at infinity. So the first in finite time, first order reaction never gets completed. Okay. Now let us quickly talk about the half-life and full life. So there is no full life, because first order reaction never gets completed. So we can never say that this is full life of the reaction. It's no term like this for uh, first order reaction. So let us quickly discuss about half-life. At t equals to t half, Ca concentration become half of the initial. As I explained earlier, the definition of the, okay. So if we put in this, so we get ln, this is our equation. Okay. So ln Ca equals to Ca naught by 2, Ca naught by 2 divided by Ca, this equation I am putting, equals to minus kt. Sending this minus to this side, I think everyone understand. Ln Ca upon Ca naught, sorry, Ca naught upon Ca naught by 2 equals to kt. This cancel. So we will get ln 2 equals to kt. So t equals to t half. Okay, sorry, t half. So t half is the time ln 2 by k. So this is the constant time. Like in first order, zeroth order reaction, we have seen that this half life depends on the concentration of it. But here we can see that it's ln2. It's already constant number, which we know that 0.693 its value. So if I write is at 0.693 divided by k. Rate constant is also a constant value for the given reaction. So half-life of the first order reaction is always constant. What does it mean? It means that if at t equals to 0, Ca is equals to, let's suppose, 100, any quantity. I'm not writing the units also. That's 100. So it will be 50. This Ca will be 50 in x time. X time, okay? X time. So this Ca will be 25 in x time only. and this CA will be 25 of half, like 12.5 in this X time only. That's what is mean by constant half-life. So I think my time constraint is over. So I would like to finish topic. Okay, if time permits, let's discuss the rate constant. Rate constant is very important. Can't leave it. So let's talk about the unit of rate constant. So we know that minus RA equals to dCA by dt is equals to KCA to the power of n. Okay, for nth order reaction. Now we have to determine the unit of the rate constant. So we know the unit of the concentration, that is mole per liter. Okay. Now we know the unit of time as second. Let us take it as I unit second. K is K and the Ca is mole per liter, the power n. Okay, raised to the power n. Now K unit. So K is equals to mole per liter power 1 minus n into second inverse. Okay, this is very important, very important. We are directly asked in the examination, what is the unit of first order rate constant, what is the unit of second order rate constant. So by this formula, if you put the for zeroth order, let's talk about, I am giving you the quick example for zeroth order. Let's talk about first order. For first order reaction, n equals to 1, we put n equals to 1 here. Okay, k equals to 1 minus 1 0. This any quantity to the power 0 will give constant, so it will be 1. So k equals to second inverse. Okay, directly by this formula. So I request everyone to remember this formula. This is very important. Okay, so I think my time is over and I would like to thank you for watching this video. Thank you.